Okay, we've got an enclosure here we're trying to build. Two sides are made of brick and are each of length L meters, and three sides are made of wood and each is of length W meters. The brick sides cost $112 per meter, and the wooden sides cost $48 per meter. So what is the maximum area you can enclose for a budget of $16,000, rounded off to the nearest square meter? Well, the total cost of this enclosure is going to be $16,000. And that's the cost of the brick sides, which are $112 per meter, and there's L plus L, or 2L meters of the brick wall. The cost of the wooden side is $48 per square meter, and there's 3W. 3 times W is the number of of meters. $48 per meter, 3W is how many meters. That's the cost of the wooden side, just as this is the cost of the brick side. Now I notice that it looks like 4 will divide into everything, so we can make everything smaller by dividing by 4. So if I divide by 4 on both sides, just dividing every term by 4, this is 4,000 is equal to, let's see, 112 divided by 4 is 28, so it's 28 times 2L plus 4 goes into 48 12 times. Now notice I could still divide both sides by 4 again. So let's just make it as small as possible here, dividing each term by 4. It's like multiplying both sides times a fourth. And we end up with 1,000 is equal to 7 times 2L. This 4 goes into 28 7 times. This 4 goes into 12 3 times 3W. So finally, we get this nice equation that 1,000 is equal to 14L plus 9W. That looks a little nicer. Okay, now what we're trying to maximize here is the area. So let me write down the area function here, the area equation. The area is equal to the length times the width, simply. And so we need to solve for one of these variables in terms of the other to substitute into this equation. So let's solve for W, I guess, in terms of L. So if we solve for W, we have to take 14L from both sides. And we get that 9Ws is equal to 1,000 minus 14L. And if I divide both sides by 9, we get that W is equal to 1,000 divided by 9 minus 14 divided by 9 times L. And now, with this, we're going to substitute this equation into the area equation. What we get when we do that is that the area is equal to L times 1,000 divided by 9 minus 14 ninths times L. I could also factor out a ninth from that. This looks a little better if I factor out a ninth, I think. So the area is equal to L divided by 9 times 1,000 minus 14L. Anyway, this is a parabola, and actually let's distribute it. We know that the area is equal to 1,000 L divided by 9, or 1,000 divided by 9 times L minus 14 divided by 9 times L squared. In this form we can sort of see better how to find the vertex, because This is a problem where the area, say, is the vertical and L in this case is horizontal, and the area as a function of L is a parabola, and the maximum area will be attained at the vertex. So we're looking for the vertex of this parabola. I'm going to leave this here, though. This will be easier to compute with later. So the area, let's put the area equation right up here. So the area equation turned out to be -14/9 times L squared plus 1,000 divided by 9 times L. Okay, so now let's find the vertex. The L coordinate of the vertex, negative b divided by 2a, in this case is negative 1,000 divided by 9 divided by 2 times the a term is negative 14/9. So in other words, this L coordinate of the vertex, that's the value of L that will yield the maximum area, is equal to, the negatives cancel, and negative divided by negative is a positive, and 2 times 14 is 28. So this is 1,000 divided by 9 times, the reciprocal of the denominator is 9 over 28. The 9's cancel, and that's not all that cancels. We can reduce it down a little bit further. 1,000 divided by 28, see, 28 divided by 4 is 7. So this is the same as 250 divided by 7. If you divide by 4, you get 250. If you divide by 4, you get 7. So that's the length that will yield the maximum area. So if we substitute it into our equation, also we're rounding it off, so we might as well do it numerically at this point. That length is 250 divided by 7 is about 35.71428 anyway, approximately, and that's in meters. So plugging that into our equation, in this form it's easier to compute when it's factored like this. So substituting in our value for L, 35.7142857,143, here's what we get. Times 14, that's equal to 500 exactly. So 1,000 minus 500 is 500. And our L times 500, then divided by 9, gives us maximum area is equal to 1,984.126. Well, we want to round up to the nearest square meter, so that's the 4. So the maximum area is approximately equal to 1,984 square meters. So that is our maximum possible area, rounded off to the nearest square meter.